Good morning. I am Dr. P.M. Shanthi, working as Assistant Professor in the Department of Information Technology, JJ College of Arts and Science, Pudukottai. Now we have to discuss about the concept of advanced databases. Before that, you can discuss what is in by data and then database management system. Data is a collection of information that has been translated into a form that is efficient for movement or processing. The information, the knowledge about a particular subject, issue or event or process. There are three different characteristics we can use it in the data. Timely, information should be available when required, and then accuracy, information should be accurate. Completeness, information should be complete. The another one, database. A database is an organized collection of structured information or data typically stored electronically in a computer. And then another one, database management system is a software designed to store, retrieve, define and manage data in a database. Example, MySQL, Microsoft Access SQL Server. Here we can discuss about homogeneous and heterogeneous database, distributed data storage, data fragmentation, transparency, distributed transaction, commit controls, concurrency control in distributed database. Introduction. A distributed database is a database that consists of two or more files located in different sites, either on the same network or on entirely different networks. Portions of the database are stored in multiple physical locations and the processing is distributed among multiple nodes. Features: location independent, distributed query processing, distributed transaction management, hardware independent, operating system independent, network independent, transaction transparency, DBMS independent. Then types of distributed databases. There are two different types of distributed databases. First one, homogeneous distributed database. In a homogeneous distributed database system, all sites have identical database management system software, are aware of one another and agree to cooperate in processing users' requests. And the second one, heterogeneous distributed database. Heterogeneous, its different sites may use different schemas and different database management system software. The sites may not be aware of one another and maybe provide only limited facilities for cooperation in transaction processing. Next one, distributed data storage. A relation R that is to be stored in the database. There are two different approaches to storing these relations in the distributed database. First one, replication, and second one, fragmentation. Replication means the system maintains several identical replicas, that is copies of the relation, and stores each replica at a different site. The alternative to replications is store only one copy of relation R. Fragmentation. The system portions the relation into several fragments and stores each fragment at a different sites. Fragmentation and replications can be combined. That is, a relation can be partitioned into several fragments and there may be several replicas of each fragment in the following form. Data replication. If a relation R is replicated, a copy of relation R is stored to or more sites. In the most extreme case, have full replication, which a copy is stored in every site in the system. There are number of advantages and disadvantages of replication. First one, availability. If one of the sites containing relation are fails, then the relation are can be found in another site. Thus, the system can continue to process queries involving or despite the failure of one site. And the second one, increased parallelism. In the case where the majority of access to the relation are result in only the reading of the relation, the several sites can process queries involving R in parallel. The more replicas of R there are, the greater the chance that needed data will be found in the site where the transaction is executing. Increased overhead on update. The system must ensure that all replicas of a relation are consistent, otherwise erroneous computations may result. Thus, whenever R is updated, the update must be propagated to all sites containing replicas. The result is increased overhead. Example, in a banking system where account information is replicated in various sites, it is necessary to ensure that the balance in a particular account agrees in all sites. Another one, data fragmentation. If a relation R is fragmented, R is divided into a number of fragments R1, R2 up to Rn. These fragments contain sufficient information to allow reconstruction of the original relation R. There are two different schemes for fragmentation relation. First one, horizontal fragmentation and vertical fragmentation. Horizontal fragmentation splits the relation by assigning each tuple of R to one or more fragments. Vertical fragment splits the relation by decomposing the schema of R of relation R. Next one, transparency. Transparency, the user of a distributed database system should not be required to know where the data physically located or how the data can be accessed at the specific local site. These characteristics is called data transparency. There are three different types of transparency. First one, fragmentation transparency. Second one, replication transparency. Third one, location transparency. Fragmentation transparency. Users are not required to know how a relation has been fragmented. And then replication transparency. User view each data object as logically unique. This distributed system may replicate an object to increase either system performance or data availability. Users do not have to be concerned with what data objects have been replicated or where replicas have been placed. Another one, location transparency. Users are not required to know the physical location of the data. The distributed database system should be able to find any data as long as the data identifier is supplied by the user interaction. Another one, distributed transaction. Access to the various data items in the system is usually accomplished through transaction must preserve the ACID properties. There are two different types of transaction, local transaction and global transaction. System structure. Each site has its own local transaction manager whose function is to ensure the ACID properties of those transactions that execute at that sites. The various transaction manager to cooperate to execute global transaction. To understand how such a manager can be implemented, consider an abstract model of a transaction system. It will be divided for two different subsystems. First one is a transaction manager and then another one is a transaction coordinator. The transaction manager manages the execution of those transactions that access data stored in a local site. Note that each transaction may be either local transaction or part of a global transaction. Another one, transaction coordinators. It coordinates the execution of various transactions, both global and local, initiated at that site. And then another one, system failure modes. A distributed system may suffer from the same types of failure that a centralized system does. There are, however, additional types of failure with which need to deal in the distributed environment. The remaining concept discussed in upcoming session.